like I said, the hardest part of Year 11 methods at the start is quadratics. You get your head around quadratics, cubics becomes easier, and then that means your algebra strength is much more improved, and you're ready to tackle the other topics. So the hardest part of Chapter 3 is discriminants. Inequalities and discriminants. Anything before that, if you're finding it difficult, you have to master those skills. So 3A all the way to 3F, you have to be able to sketch quadratics. If you can't sketch it, you can't analyze it. You can't analyze it, you can't do anything in methods. Okay? So do go back, make sure you master that. And the reason why I'm emphasizing that now is because coming to 3L, if you find that difficult, it might be partly because you can't sketch it. You can't analyze it. Because if you can't analyze it, you can't apply it. Okay, so there's no point of me talking about 3L and going through all problems if you can't sketch it. If you don't know how to factorize, if you can't draw the picture and figure out what's your maximum minimum and analyze that graph, then there's no point. So go back to 3A to 3F. That has to be mastered. And then you'll understand 3I, 3J, which is discriminants. Then you can do all this pretty easily. Okay? So, applications, I'm just going to choose one. And I'm going to get you to go onto that and just have a look if you're ahead, if you're up to date, to move on to 3L. Otherwise, I highly encourage you to go all the way back. Make sure 3I, 3J, all the discriminants make sense. If they don't make sense, there is no point. Literally, there's no point in me trying to teach you applications. You have to go back. Okay. Now, let's have a look at this example. This is from your textbook anyway. So it says, Jenny wishes to fence off a rectangular vegetable garden, okay, in a backyard. And because it's a rectangular, first things first, once you're up to this stage, in order to do application questions, I highly encourage you to draw. Draw the problem, visualize it, try to solve the problem once you look at the problem. Okay, so look at it, draw it. Once you can see it, you can probably solve it. Is that a question, Renata? No. No? Okay. And now, so I know it's a rectangular problem. I'm like, okay, I've got a rectangle. So I draw a rectangle. Yeah? And so she has 20 meters of fencing wire, which she will use to fence 3 sides of the garden. So that means only 3 of the sides are going to be fenced off, and 1 of them is going to be left free. So I know 3 of them, fence has to add up to 20 meters. Okay, so what that really just tells me already is the perimeter for 2 sides and 1 length will give me 20 meters. Okay? Then it says, with the existing timber fence forming the 4th side, okay, calculate the maximum area she can enclose. Now, at first it sounds difficult.
Which side's the fence? Wait, which is the timber fence like?
You can choose either, it doesn't matter which one, because we don't know, it doesn't tell you which one's length or width. You can name whichever you want. Okay? So in my case, I just went with length, width, and I just went, that's your timber fencing. Okay? Now here's the thing, because I just put some values, it doesn't matter where you're putting it in. You just know that 2 times a certain side, it has to double on side. So if it was this side and that side that are fenced, then it would have been this side plus this side plus this side. That would have been 2L plus W. So it doesn't actually matter which one. I'm just modeling it. I'm just saying, all right, 3 sides out of the 4, one of them has to double. So I got 2 W's plus a length should give me the perimeter. But they told me that I've got a 20-meter fencing, so I can say, all right, well, that means 20 in total has to give me length plus 2W. Does that make sense so far? Yeah, so I've drawn a diagram, I've labeled it, I've understood the problem, I've understood the first line, and I've just written out my first equation for the first line. Now, it says here that you now have the existing fence forming the 4th side. You can actually rearrange this. You can say, well, if length, wait, where is it? It says, therefore, length is L, and you can say width, and you rearrange this equation, you can write width in terms of length. Okay, so what I mean here is I'm saying, all right, if you have 20 equals length plus 2W, you don't know what W is. Oh, good day.
All right.
Yes, he's here today.
Can I talk to him?
Yes, you may.
And that's him, isn't it?
Sounds very shifting. This is being recorded, by the way.
Is it?
Yeah.
Hello.
Does he have to bring his bag?
No, just bring yourself. Only be a minute.
It'll just be a minute. All right, so if you want to get W by itself, you solve it, and you say if you minus L on both sides, you can see 20 minus L equals to 2W, so therefore W has to be equal to 20 minus L on 2. That's what I've done here. Okay, why did I do that? Because you can't solve something if you have two unknowns. You need at least them all to be the same. So it's like y equals x squared. You've got all the x's in one row. You don't have multiple letters, multiple variables. Okay, so that's what I did. And then what did they ask you to do? They said calculate the maximum area. So when it comes to area, that's my second piece of information. I said I want length times width to give me the area. But length I already got, I called it L. Width, I've rearranged it so I got the letter L in it. So it's 20 minus L on 2. So if you work that out, length times width, and now this is just simplifying, numerator by numerator, that gives you, well, I changed it to x so it's easier for you guys to understand. I changed it to x, x times 20 minus x on 2. And you can expand this if you want. This would give you 20x minus x squared all over 2. And that technically is 10x minus half x squared.
Why did you change it to x's?
I changed it to x because if you type in your calculator sketch, it makes more sense. Your calculator doesn't graph with L, but theoretically that still x represents your L. I'm only doing this for your calculator and for you to get used to sketching. A should technically be your y values, but technically it should be A and L. Okay, I'm just changing it to this so it makes it easier for you to solve. Yeah? So what you really have now is this. You got the area is equal to whatever x is times 20 minus x on 2. That is a quadratic graph. If you expand it, you can see it's 10x minus half x squared. That's a quadratic graph there. Now I normally don't expand it because this is already factorized for you. Because it's factorized, the nice thing is you can use null factor law to figure out what the graph should look like, or use your calculator. Sketch, analyze. Okay, so if we were to analyze this now, oh, sorry, I'll just write it out again. 20, and that would be 10x minus half x squared. Okay, now if we were to sketch this, what I want you to see is, if I gave you this, if I originally gave you y equals to x bracket 20 minus x on 2, okay, and I asked you to sketch this graph, what are the three things you need to sketch? Yeah, you need x-intercept, y-intercept, and a turning point. Yeah?
The one with the two bracket version.
This is the one with the two brackets. You've got two x's, you've got x and an x. Just because I don't put a bracket around here doesn't mean you don't have two brackets. It's technically the same as that. So what you can say is, you can find the y-intercept, which is the easiest one to do. If you want to find your y-intercept, what do? Make x equal to 0. So you know that x has to equal to 0, so y must equal to 0 times 20 minus 0 on 2. Now we all know that 0 times anything, 0. So logically it's 0. That's the y-intercept. What about the x-intercept? If you want to find the x-intercept, what do you have to do? Make y equal to 0. And so that makes this equal to 0. And the nice thing is you got 0 equals to x.
Is it not?
Yeah. You see, this is two numbers multiplied to each other. One of them has to be 0. If this was 0, then you got x equals 0. If this had to be 0, now you got 20 minus x on 2 has to equal to 0. Solve for x. In this case, x has to equal to what? 10. So right now, graphically, what I want you to see is you got 0, 10. Yep. Is it 20? Oh, no, you're right.
Times the 2 across.
Well, you got me too.
So you times the 2 across, and then you minus the 20.
And divided by negative. So you can do times both sides by 2. You get 20 minus x equals to 0. And you can say add x on both sides. So that makes it 20 equals to... Yeah. Okay. So now, if you do that, you've got 0 to 20. And you can clearly tell that this is a negative graph because x times negative x is negative x squared. So it has to look something like this. The one thing I want you to pay attention to, and this is what I will probably do on your SACs as well, is it possible to, you got to think about it application-wise. If I'm saying x is 0 and I put a dot there, it means that x can equal to 0. Does it make sense that the length can be 0?
Yeah.
No, it can't. But then also at the same time, when you're talking about lengths, isn't length longer than the width? Yes, it is. So that means it doesn't make sense if I had length as 1 and width is 2. That wouldn't work. No. So there's also conditions on what your length and width can be. Now that's actually analyzing now. You have to analyze what can the width be and what can the length be, and therefore this would be more restricted.
Why couldn't you just stick it like 5, 10, 40? With a fitting.
Yeah, you can.
No, the other way around. So the 5 is with the W's.
Yeah, you can. That's just one possible. So you're saying that when
Maximum area.
L is 10.
It wouldn't be the maximum area.
Okay, now maximum area is obviously up here. You see, the graph that you just got here is depending on x. If x was 5, like you just said, if x was 10, then you have 20 minus 10. It's 10. 10 divided by 2 is 5. So you're right, that could have 5 and 10. And it happens to be, yes, in this case, it is the maximum as well. But in most cases, you can't just say that has to be halfway. Okay, you have to calculate it, and you're calculating the turning point. Yes, Trent?
So why is it negative?
Why is it a negative graph? Because if you expand this, you can see that x times a negative x gives you overall negative x squared. Or, see? Because it's negative x squared, if you expand it, you get that. So you know that it has to be a negative graph. And then if you want to find your turning point, remember, how do you find the turning point of a general equation? You can use two methods here. You can either use x equals to negative b over 2a, or since you've got the x-intercepts, remember the turning point is where the halfway is, which is your right. In that case, if it's 20, half of 20 has to be 10. So therefore, when length is 10, you can then work out your area. In that case, you figure it out. If that was 10, this would be 5. 10 times 5 gives you 50. Okay? But the one thing I'm trying to tell you for my SACs, what I'm going to be doing is I'm going to want you to analyze what W and length can be. In this case, they don't talk about length and width. That's why it doesn't matter. But normally it does. Because whatever the length can be, if the length is twice the width, it doesn't make sense to have width larger than the length. Because according to this, it can. See, I can have a very small length and a very large width. That doesn't make sense. If I gave you a condition at the start, if I told you that the width has to be, half the size of a length, then that would be wrong. Okay, so that means your restriction won't just be from 0 to 20, it might be from 0 to 15 or 18. Okay, but I'm going to leave that there. I'm going to find another example for the next session in our practice where you see what I mean by restricting what the width and length could be and how that affects your graph. Yes, Trent?
Just quick on the partition,
Yeah.
the y-axis is area and the x-axis is length of mesh.
Perfect. Because we technically had A and L from the beginning. Okay? When you're sketching the graph as well, because we already know that length can't be 0, and it doesn't make sense to have 0 area as well, that means at 0 and 20, you should not have a closed circle. Instead, your graph should look like this. And I'm going to rub everything off. And you can see the graph, the way you should be writing it, should be like this. Open circle at 0, goes up, comes down, open circle at 20. Why open circle? Because it means you can't have that value there. Okay? Now maximum, you label your maximum and you know that this is 10 and that's 50. Area, length. That's your 10. Okay? Now in this question here, you're not restricting the domain, but in my SACs, I'm going to give you some questions so you can see what I mean. And in the exams, if you look at previous exams that I've wrote, then I always make sure that you have to analyze these because that's the skill. The skill is you need to analyze everything that you're doing. Everything has to make sense. You know, length, width, that's why it's called applications. Otherwise, you're just doing mathematics. Doesn't mean it's applications. Okay? So this example here, you don't have to think about restrictions, but later on, every line matters, and in the condition, it does matter as well. And I'll give you an example when we get to the revision next week. Okay? But this is for 3L. If you are ahead and you're up to date, go to 3L. Otherwise, I want you to go back 3A, 3B, 3C, 3D, all the way to 3F. You have to be able to sketch, turning point form, general form, regardless of whichever method, and then discriminants. Okay, those are the three I want you to have. Okay, so you have to be able to sketch turning point form, sketch general form, and then discriminants. Those are the three you have to be able to do. Okay, but if you can do all that,
Why is there 50? Like,
how?
50 useful for the equation?
How's 50?
Like, how do you analyze the result? Does that
To the question.
Yeah.
The question asks you for the maximum area.
And if 50 is the area.
50 is the area, because that's what this is representing. We're saying area will equal to length times 20 minus length divided by 2. What we found out is the turning point is actually where the maximum area has to be. And the turning point was when length was 10. So if length is 10 times 20 minus 10 divided by 2, that's 10 times 5. That's why I know the area has to be 50. Okay. All right. Remember, if you have problems with sketching, let me know. Because the earlier you get to me, I can help you. Otherwise, the later it is, the worse it is.